let's see if we can define the piecewise function given right here. So if you remember, piecewise functions are usually written f of x or some kind of g of x, h of x equals, and then I have the bracket. And this particular function I can see has two pieces. I have this piece right here, and I have this piece right here. And we usually work from left to right. The top one is the one that is the farthest over to the left, and we work over to the right going down the list. So this is going to have two pieces, and the first piece is going to be the piece that's farthest to the left, and then we'll just make that our green piece right here. It's a diagonal line. So if it's a line, the equation is going to take the form of y equals mx plus b. So let's see if we can't figure out what, so m, as you'll recall, just so you remember here, m is slope, and b is the y-intercept. And it's the y-intercept because when x is equal to 0, so when x is equal to 0, in any equation, y equals mx plus b, this piece is going to be equal to 0. All I'm going to be left with is the y, so I will have the point 0, b, which is going to be on the y-axis. So let's see if I can determine the slope of this line. Well, it looks like I go to left 2 and up 2, left 2, up 2. I can see this has a negative slope. It's going downhill. And I'm going an equal distance both ways, rise and run. So my slope is -1. So I have -1x, and my y-intercept is +2. You can't see it very well right there because it's kind of covered up. But you can see that this graph is in 2, but my y-intercept is +2. So my first function here is -x plus 2. So -x plus 2, but I only want it for x's that are less than 0. All these x's here are what I want, but only for where it's less than 0. So for x less than 0, not less than or equal to, because it's an open circle. And while I was drawing that, I just noticed I have another piece right here. So this is going to be my middle piece, that one right there, that red dot that I just drew. And that middle piece is just a single point, and it's the point y equals 4. So let's do that in blue. Y equals 4, and that only happens where x is equal to 0. That piece, any kind of a point is really pretty easy to find on a piecewise function. It's really easy to write on a piecewise function because it just is, well, whatever the y value is at that particular x value. So now I got this third function right here. It starts right here with an open circle at 0, and it goes up like that. Again, I need to do y equals mx plus b. I can see that it's a positive slope. This is a hard positive slope to figure out. You know that? Well, I start here at -3. So this is the point 0, -3. So I can see that -3 is going to be my b, so I can write that in right there. And it looks like this is the point, this point right here is the point 2, 1. I'm going to assume it's 2, 1. I sure hope it is. We're going to go with it. So 2, 1. That's the point 2, 1. So let's do slope the old-fashioned way. y2 minus y1 over x2 minus x1. So we'll go 1 minus -3 divided by 2 minus 0. So that is 4 over 2. That's telling me that has a slope of 2. And that looks reasonable enough. So this would be y equals 2x minus 3. Okay, so we'll put that here, 2x minus 3. But that is only, again, from 0, x is equal to 0, and then going on forever. So this is for where x is greater than 0. So if I want to, whoops, don't do that. If I want to find the domain and range of this particular function, really it's easy to find this one here just looking at these numbers here, because I have all x's less than 0, equal to 0, and greater than 0. So the domain is pretty clearly negative infinity to positive infinity. And I can see the same thing on my graph. I cover all the x's from negative infinity all the way up to 0. Then I cover them at 0, and then I cover them above 0. So my domain is negative infinity to positive infinity. My range is a little bit different. My range starts over here at negative 3. That's my lowest y value. Negative 3. And actually, this line just now goes all the way up to infinity. So the fact that I have this over here and I have this dot is really kind of irrelevant, because those y values are covered by this line there. So that goes all the way to infinity. That would be my domain and range of that problem.